8.1, hypothesis testing. Okay, so you notice I got my screen there. I got still the same application problem and context. I got my null hypothesis and alternative hypothesis, which we came up with in that first video. All right, what I'm going to do in this video is kind of talk about steps 4 and 5, okay? Steps 2 and 3 is really the application process. This is what's going to be the meat of our next section, 8.3. As you recall, I talked about how I chose 8.3 over 8.2 for those reasons I expressed in the email. Notice that I'm not skipping over these on purpose, like I don't want to touch them. It's just that I need an application problem to do this, okay? And so I will get to that when we do the 8.3 video. In fact, I encourage you right after watching this video is that you jump to 8.3 and you watch that video to see the whole thing in action with the problem and doing all the math, okay? So strongly encourage you to do that. All right, so let's get into this problem. Put yourself in my situation. I've been playing some soft music. I got the data from looking at how the students did on the test. Now I need to make that decision. Let's look at situation B. Is my playing soft music having a positive impact, meaning my students' grades got better by me playing the music, okay? So if we take a step back, this is the part where, as you as the scientist, or me as the teacher in this case, to make a decision whether I see the possibility of it having a positive impact on student grades. Okay, so what this is going to bring up, how I'm going to say whether or not it does, is I have to determine whether to accept the null hypothesis. So that's this right here. I don't like how they say do not accept, do not reject the null hypothesis, which means I accept the null hypothesis, or I can reject the null hypothesis, okay? Which means to reject the null hypothesis means that, yes, I saw an increase, or I don't think that the increase was enough to say that it had an impact or not, okay? So the one we're going to look at, so if you look at this one, so let's put this into context. So let's say, for example, I rejected the null hypothesis, meaning, man, soft music has a really great impact on my student's grade. But in all actuality, that wasn't the case. And so that should be called a type 1 error. This is an error that people make all the time. They think that something has an impact on the grades, they go whole hog into it, and then they find out, man, that it really didn't have one. So that would be what's called a type 1 error, okay? A type 2 error would be, let's say, for example, I accept the null hypothesis, and it so happens that the null hypothesis was false. Now, putting that in context, that would be hard to press, and that's why in our particular section here, we focus primarily on that type 1 error, okay? And I crossed this out, this type 2 error, just to show you that that is a possibility, that maybe I accept the null hypothesis and that it was, in fact, a false null hypothesis, but that's not what we're going to be worrying about. And in fact, statistically, that's really hard to prove. So our meat of what we're going to be doing is what's called a type 1 error analysis. So what we have here is the notation for a type 1 error, or something we want to, could happen, is what's called the alpha. So it looks like this, quiz question, by the way. All right, so the symbol for a type 1 error is the alpha. All right, so let's dive into this here a little bit. Now, the question that might come up is, well, what happens, if I know that the average grade is 70? At what point is the cutoff for me to say, man, I think playing music is a really good thing and it's having a positive impact on my students? What is that cutoff? Well, to find out what that is, that's your level of significance. Okay, so this is the level that you're willing to say that the data that I have. There is a 10% chance I have a type 1 error, there's a 5% chance I have a type 1 error, and there's a 1% chance I have a type 1 error. Okay, so the level of significance, these three levels are arbitrary. This is just what statisticians use. You could use any level of significance you want, but primarily you're going to find these three are used by statisticians. All right, so let me put this into, bring it back to context, this level of significance. So let's say, for example, we keep using situation B, so let's go with it. Let's say, for example, I run a test and the level of significance I want to use is, let's say, 10%, okay? So, or 0.10, sorry, I use percents because they're more applicable because we get them, but let's say I want to use a level of significance of 0.1, okay? So that would mean that this would be 0.1 here, and this would be 0.9, okay? So now let's bring up this thing right here. the critical value separates the region of the non-critical region. The symbol for the critical value is CV. So right here is that breaking point of CV. Okay, so that's the critical value. So what we have here, and in our particular thing with 8.3, is this going to be our T right here, okay? T. If you were doing 8.2, which is where we know what the standard deviation of the population is, then we would use the Z table, okay? Similar to 7.1 and 7.2. In fact, 7.2 8.3 is an extension of 7.2 using the T table, which I'll talk about again in 8.3. So let's get back to this. So let's say, for example, I've suggested I'm using a level of significance of 0.1. All right, I put it over here because, again, we're talking about increase. So this is the level right here, the level of significance. All right, I want to call this a right-tailed. Okay, so and again, a one-tailed, but one-tail test, also right tail. All right, because there's only one area I'm looking at because we're just increasing. All right, so if I were to, big picture stuff here, if I were to say, all right, so I've done my test and I've found the critical value. I'm willing to accept a possibility of a type 1 error by 10%. So if my data point falls within this region here, it would fall in the critical area, meaning I would reject the null hypothesis. So if my value that I have in here, again, I recommend right after this video watching 8.3 and you'll see the whole big picture stuff. But if my value, my sample mean that I got, falls within this critical area, I am going to reject the null hypothesis with the idea that I could be 10%, there's a 10% chance that I could be making a type 1 error. Okay? All right. So let me put it again. Let's flip it to the other side now, okay? And hopefully maybe you're kind of catching on here. So let's say, for example, I'm doing this one. Let's say I'm seeing that maybe playing the soft music has a negative effect on student greens, meaning I shouldn't probably do it, okay? So let's say I'll do this one as a level of significance by 0.05, okay? So let's say this is 0.05. And so that would make this 0.95, okay? Again, this region right here, I'll color it in red with this is the critical region. This is the region that if my sample means falls within that area, that would mean that I would reject the null hypothesis. If by chance my sample mean falls in this area, I would interject or say that my playing soft music really doesn't have an effect on whether or not students do well or vice versa, okay? So do well or it doesn't have any impact on their grade, okay? So again, I want to emphasize, let me repeat that again because this is important. So if my sample mean falls in the critical region, I would say, man, I'm going to reject the null hypothesis and I'm going to say that soft music has a bad thing with my standard quizzes. If my data point falls in this non-critical region, then I would accept the null hypothesis and say that playing soft music really doesn't matter. It doesn't have an impact whether on my testing. Okay. So last one here. Thanks for your attention here. Hopefully you're kind of seeing big picture stuff here. So let's go. This is what's called a two-tailed. Sorry, this is left-tailed. If you didn't get your right and lefts there. There you go. All right. And this is a two-tailed because in this case, as you recall, I'm just saying, does it have any impact? Whether it's increasing, decreasing, whatever, all right? So in this particular case, in a two-tailed case, let's say, for example, I want to do on this first one a 0.1 level of significance, okay? Now, if I do a two-tail, that means I'm saying whether it increases or decreases. I'm just saying, does playing music have any effect? And kind of going in with an open mind, all right? So in this particular case, I have to split it because it's two-tailed. I have to split it between both sides. So that would mean if I have a 0.1 level of significance, that would mean I'd have a 0.05 on this side and a 0.05 on this side, knowing full well that 90% is right here. Okay, so again, this area emphasizes the critical values, and this emphasizes the green is the non-critical area. Okay, so let's put this into context. I do the test, everything happens. Let's say, for example, that my data point, whoa, I don't know what I got going on. I'm painting now. Let's see, pen. All right, so let's say, for example, my sample mean information falls in this area. So it falls in the non-critical area. If that happens, that would mean I would accept the null hypothesis, meaning that me playing soft music has no impact on students' grades. Okay. On the opposite side of that, let's say, for example, my sample mean falls in this area, on the other side of the critical value. Again, these critical values are right here, which again you'll see see how that's applied using the chart, the t distribution chart for 8.3. And so let's say, for example, the critical value is right here, and it falls on the other side of the critical value. I would suspect in this particular case that playing soft music has a positive impact or increases students' grade, and I would reject. Again, that's why it's called the rejection region. I would reject the null hypothesis and state that, man, I think there's a legitimate chance that playing soft music in this particular case has a positive effect on students' grades. All right, so let's round this off here. Let's say, for example, I want to make sure when I present this to Mr. Van Sickle that that I have data that's sharp and I know it has a positive impact. Let's say, for example, I'm going to use 0.01 as my level of significance. Okay, so if you're doing a two-tailed test with 0.01, that would mean that the region outside of here would be 0.05, meaning 0.5%, and this would be 0.005, and in the middle again would be 99%. Okay, this would be a test that I want to be darn sure. I don't want to have the odds of me making a type 1 error is a 1% chance, which means if you're falling in this area, then there's a very good chance that your soft music playing has could have a positive or negative depending on what side of the critical values you line up here. So, long story short here, oh man, this is a good classroom lesson, so I'm trying my best here. So let's say, for example, in this area right here, those are my rejection regions, okay? And then those little black marks here are the critical values. Those are right there. All right, moving right along. And then, as you can imagine, I'm going to paint the green area, that non-critical area. Okay, so again, to put things into context, please pay attention. If I had my sample mean, let's say, for example, it came out to be right in this region. After doing my statistical analysis, it came out in here. Because it falls within the non-critical region, I would accept the null hypothesis and say that playing music has no effect on students' grades. Okay, let's say, for example, it falls up here. That would have a significant impact. That means that, hey, there is, I'm seeing in my results that from this sample that playing soft music during standard quizzes has a positive impact on student grades. And I'm accepting the fact, and this is important, I'm accepting the fact that I may have a 1% chance of making a type 1 error. Again, meaning that I rejected the null hypothesis and it happened to be true. Okay, so I'm accepting the fact because there is a level of where does your test break the line in saying that it does have an impact. Okay, I'm accepting the fact that there is a 1% chance that I could be doing a type 1 error. But you'll notice as I decrease my level of significance, the better possibility that I can analyze the data. Okay. So hopefully this video helped you out. Again, I strongly encourage you guys to look at 8.3 and you'll see big picture stuff on what we're doing right away. And you have a great night and or evening wherever you're at. And I really appreciate you watching the videos.